All right, so this is 8.5. This is more challenging trig equations, and I know that a lot of this material has been pretty difficult leading up until now. So what we're going to do is, all right, so this is 8.5. This is going to be higher level trig equations, and I know that some of us have struggled up until now, but bear with this. You know, the thing about this section and about most of this in general is that this is algebra skills. I know that it's a lot different seeing it as trig functions, but essentially we are still doing this exactly like we would do an algebra problem. So when you think of a problem like this, we have 4 sine squared of theta equals 3. Well, we're still trying to get our sine of theta by itself. This is almost, if you look at this, this is the exact same idea as saying 4x squared equals 3. The same operations are still going to happen. So in this case, the first thing we do is we divide both sides by 4. So that cancels out the 4. Over here, we would do the exact same thing. Then what we're doing is we're left with the sine squared of theta equals 3 over 4. Well, we want to get sine squared of theta. We want to get sine of theta by itself. So what do? We take the square root of both sides, which means we have plus or minus the square root of both sides. And that's going to leave us with the sine of theta is equal to, and again, this is the square root of 3 over the square root of 4, so that's equal to the square root of 3 over 2. So we want to know when the sine of theta is equal to the square root of 3 over 2. And again, that going back to our unit circle there, square root of 3 over 2, we draw our triangle, okay, and we want it from 0 to 2 pi, so we want a positive square root of 3 over 2, so that means we have here's theta, square root of 3 is here, 2 is here. So that means that this has to be a 60-degree angle, okay? A 60-degree angle. So we know that that is going to be pi over 3. So theta is equal to pi over 3. And then also, we know that sine is, so here's our all students, so our sine is also positive over here. Okay, so this needs to be a 60-degree angle right here. So again, we would do, we would do here pi minus pi over 3 to get us what this angle is. Because remember, this entire thing is pi. Subtract off pi over 3, and we would get 2 pi over 3. Okay, so that's the first example. Those are the two places where it would be equal to the square root of 3 over 2 in between 0 and 2 pi. Is that pi over 3 and 2 pi over 3? Because again, the goal of this is to get it down to the trig function equal to square root of 3 over 2, and then we can use our unit circle, or in some cases we can even use our inverse trig function. So in this problem, again, we're going to do this one step at a time, but here's what we're going to do. The first thing we want to do is change this cosecant in terms of sine. So that means we will rewrite this as 2 sine of theta minus 1 over sine of theta equals 1. So all we did was change the cosecant to a sine. Now we need to clear all fractions. So what we're going to do is we're going to multiply every term here by sine so we can get rid of this. So if we multiply everything here by sine of theta, this is what we're left with. 2 sine squared of theta, that's sine times 2 sine of theta, minus 1, because sine times 1 over sine will cancel out, equals sine of theta. Okay, now to try and solve this, we have a sine squared of theta and we have a sine of theta. We're going to bring everything to one side, so we're going to minus the sine of theta from both sides, so that's what we do here, and then we're going to rewrite this. So we have 2 sine squared of theta minus sine of theta minus 1 equals 0. Now, here is the difficult part about this. This is where I tell you that this all has to do with algebra. We just need to be able to see what we're trying to do. So if you notice this right here, if you assume that all of your signs are just like a variable, this is like saying 2x squared minus x minus 1 equals 0. So in other words, instead of the sign, it's just an x. So it's the same thing. So when we look at a function like this, we would try and factor it. We would try and factor it just like anything else. And this factors into 2x plus 1 and x minus 1. That's how this would factor. I mean, those are where we factor into binomials. So if that's the case, the exact same thing is true about this down here. So we're going to factor that exactly the same way, except instead of the x's, it's just going to be our signs. So that means this factors into 2 sine of theta plus 1 and sine of theta minus 1. And that is equal to 0. So what happens here is we need to now solve for each one of these individually. If this portion equals 0, the entire thing equals 0. If this part is 0, it doesn't matter what this is equal to. The whole thing is 0. If this part is 0, the whole thing is 0. So we're going to set up two separate equations here. So this part right here, 2 sine of theta plus 1, we will set that equal to 0 and solve. So that gives us 2 sine of theta equals negative 1, which means sine of theta will be equal to negative 1 over 2. So we need to figure out where sine of theta is equal to negative 1/2. We've done that before. And then also the other one, we have sine of theta minus 1 equals 0. So we also need to figure out where the sine of theta is equal to positive 1. So again, we have done enough of this using our right triangles and using our circles that, I'm not going to go into a lot of detail on this, but going through our right triangles, we would do this, and the theta, and again, we're in degrees here, so theta will equal two things. It will equal 210 degrees and 330 degrees. That's when it will be equal to negative 1/2. And then when sine of theta is equal to 1, that's at 90 degrees. So we actually have 3 solutions for this one. And again, I'm not going to go through stuff that we've already done on how to solve sine of theta equals negative 1/2. We can do that in class if you still have questions. Okay, next one. Next one is a okay, so this one's a little bit more of a difficult problem, and part of it is just kind of, being able to recognize what we want to do. And there's one trick to this problem that we need to be aware of. And what the idea here is that we need to realize what we want to put it in terms of. Obviously, cotangent squared and cosecant are not the same thing. So we need to get it as close to possible as we can, okay? So what we're going to do is we are going to get this in terms of cosecant. And the reason why we're going to do that is because cotangent squared of x is equal to, and this is using our Pythagorean relationship. If you recall, we have 1 plus cotangent squared of x is equal to cosecant squared of x. So that means the cotangent squared of x will be equal to the cosecant squared of x minus 1. So that's what we're going to do here, is we're going to replace this with the cosecant squared of x minus 1, and that's just, all we're doing is doing a straight replacement, minus 3 cosecant of x equals negative 3. And now we're just going to add 3 to the other side. So we have cosecant squared of x minus 1 minus 3 cosecant x plus 3 equals 0. Now we'll combine the negative 1 and the positive 3, and that is cosecant squared of x minus 3 cosecant of x, and then this will just be a plus 2 equals 0. Again, this works out exactly the same as it did before. We have a quadratic function, okay? It looks like this. It would be, if we put x's in there, it would be x squared minus 3x plus 2. If you factor that, that would be x minus 2 and x minus 1. So factoring that, now all we're doing is replacing the x's with our cosecants. So our factors become cosecant of x minus 2, cosecant of x minus 1 equals 0. So our two formulas that we need to solve is we have to know when this is equal to 0, which is the same as when cosecant of x equals 2, and we also need to know when cosecant of x is going to be equal to 1, because we add 1 to both sides. So we have two things to find out here, just like we did on the previous problem. Okay, so a couple things to look at here. Cosecant of x is the same thing as 1 over sine. So bringing this up here, we have cosecant of x. Remember, we can just invert everything. Cosecant of x is the same as 1 over sine. Okay, so in other words, we need to know when the sine is going to be equal to two things. Sine of x equals 1/2. We just invert everything. Invert this, and we need to know when the sine of x is going to be equal to 1. Invert this, invert this. Okay, and again, I'm not going to go into a lot of detail about when this is true because we've done this, but x right here would be equal to pi. That's one of our solutions. And x up here, when sine is equal to 1/2, would be equal to pi over 3. Actually, I'm sorry, pi over 6 and 5 pi over 6. Okay, so those are our three solutions for this one. Okay, so for this last problem is actually a little bit easier once you understand what we're trying to do here. So what I look for here is I want to solve, for one of, obviously I have a sine and a cosine. So the first thing I think of is when I have sine and cosine, I want to get it into one term. So when I see both of them at the same time, I think tangent. So what I'm going to do is I'm going to divide both sides by cosine of x, because the sine over the cosine is equal to the tangent. So that means we have 4 equals tangent of x. And honestly, the only way that you're going to do this is with a calculator. So you're going to put this into a calculator, so you'll have the inverse tangent of 4 is equal to x. And we're going to get one value. It's going to be 1.326. Now, if you recall, we've talked about this a number of times. The way tangent works is the numbers repeat themselves every single pi. So if I want to know when tangent is equal to 4, it's going to equal 4 every pi. So once I figure out my first number, to get my second number, it's just going to be 1.326 plus pi, and that is equal to 4.467. So my two solutions here are x equals 1.326 and x equals 4.467. Okay? Again, it's the same thing that we were doing in section 1. Once we take the inverse, we just have to figure out when it shows up again, and the tangent shows up every pi. So, you think of it like this. The first tangent showed up here, and then the other tangent shows up here. Okay, so it's always 180 degrees or pi away from each other. Okay, so that's it for this section. We will be spending a couple days on this section, so please bring questions to class, and we'll see you then.